Good evening. My name is Kevin Johnson. I'll be giving you a speech on crop genetics. Crop genetics is a real solution to the problem of feeding an ever-growing global population. Many countries around the world are experiencing not only crop failure, but the failure of crops in consecutive years. Biotechnology has proven that it can create plant species that resist droughts and disease. We have the solution to the problem. The problem we face now is using the solution in the correct manner. Before I begin, I'd like to give you a brief understanding of the history of farming. When humans made the transition from hunter-gatherer to farmer, they did it for specific reasons. They could produce enough food to support a growing population, and they could produce it in a small area, which provided safety, security, and dependability. No longer did they have to fight other tribes for their food, and if they couldn't get it from an animal, they could always rely on their crops for food. In the Middle Ages, other advancements were achieved. They started farming in square fields, and they used strip farming. That is, they would plant one row or one strip of the field with crops, and the row adjacent to it would be left fallow. That is, they would let it recover over the year so it would be better fertile for the next year. Also, they would only replant the best seeds. If they wanted a seed that was drought resistant, they would take the seeds that were more drought resistant and plant them the next year. This was the first attempt to alter the genetics of crops. Through the 17th and 19th century, they brought forth many advancements in crop genetics to include plows, seed drills. Instead of planting by hand, they could use a drill to plant seeds, and obviously tractors. But the most dramatic change came with the emergence of modern crop genetics. When a herbicide company named Monsanto discovered in 1984 that it could produce seeds that were tolerant to their weed-killing chemicals, they began to invest in biotechnology. In 1999, they produced plants resistant to the popular herbicide Roundup. They produced the corn, cotton, canola, and soybean. And these are what they call Roundup Ready. The seed is resistant to the chemical, and the chemical will eradicate everything except for the seed. So there's no competition between the seed and weeds. In 2005, 8.5 million farmers in 21 countries were planting 1 billion acres of Monsanto seeds. It became very popular very quickly. It was resistant to chemicals, they could produce more bushels, and it was readily available. Monsanto could produce the seeds in more abundantly than the farmers could use them or wanted to use them, because some farmers were reluctant to use a genetically altered crop like Europe. Europe does not use them. They did not have to alter the plants in the lab. They could have used what they've been using for 10,000 years, which is what we went over before, the selection of different plants that were what they wanted. They didn't have to alter the seed in the lab. But the selection was time-consuming, and it was very expensive. Today, Monsanto is a leader in genetically altered plant technology. In order to corner the market of seeds, they quickly, as soon as they found out they could genetically alter plants, they tried to take out patents. They tried to take out patents, and they tried to buy up as many seed companies as they could. They bought up every seed company except for Pioneer. And Pioneer, they still have a little bit of control of Pioneer because they use Monsanto seeds. It was illegal in the 1930s, according to the PPA, the Plant Protection Act, to patent living organisms. You couldn't patent people, animals, or plants. But they were able to pressure Congress. In the 1970s, they passed the PVPA, or the Plant Variety Protection Act, which allowed them to patent those. And today, they invest 85% of their budget into biotechnology and patenting these plants. On the outside looking in, crop genetics looks like an answer to the world's prayers. More tolerant plants live longer. Higher yields means more food. It can support other industries like corn for the ethanol industry and soybeans for the biodiesel industry. Lab-created plants also have a detrimental effect. They can cross-pollinate. That is, you can take a genetically altered gene and it can cross-pollinate with all the other plants in that area. exports to Europe. Europe will not import our genetically altered plants, so the farmers lose a lot of money. And genetically non-diverse. Each plant is like the brother of another plant, so it's identical. So when they cross-pollinate, there's no genetic diversification, and that can lead to widespread crop failure. Well, loss of natural plant genetics. Today, 50% of soybeans, 50% of corn, and 85% of canola cannot be considered natural. In conclusion, genetically altered crops produce more and are more reliable, but not as genetically diverse, and they can lead to crop failure. They can spread, the genetic diversification can spread to other crops, contaminating them. Thank you.